This is the walkthrough for the specific heat problem from the specific heat video. And the question is, how much heat must be supplied to a 500 gram pan to raise its temperature from 20 degrees Celsius to 100 degrees Celsius if the pan is made out of iron? So the equation that we're going to need is the heat equation. So Q, or heat, is equal to mass times the specific heat of the substance times the delta T, or the change in temperature. So in the problem, we are given the mass of the pan, so 500 grams. We are given the temperature change, so 20 to 100. And if you are going to be given one of these problems, you will be given the table here for specific heats. That will include the materials that you need. So if we look here, iron has a specific heat of 0.11, and we know it's calories with a little c because we're working with grams since our mass is in grams. If our mass was given to us in kilograms, then we'd be working with kilocalories, or calorie with a big C. So we know our specific heat is 0.11. So if we put the information into our equation, it's going to look like this. So 500 grams for the mass times our specific heat of 0.11 times the difference in the temperature. And the difference is going to be written this direction because we want to raise it to 100 from 20. So we're going to subtract 20 from 100. That's going to get us the 80 degrees. That's the difference. And it's positive because that we're going to increase. And if we plug those values in and calculate it, we get 4,400 calories. So it's going to take 4,400 calories of heat in order to heat up that pan to the 100 degrees Celsius temperature. So the next part of this problem was, well, how about aluminum? What if the pan was made out of aluminum instead of iron? How much heat would it take to do that? So we're going to use, again, the same equation. The values are the same for the aluminum pan. It's still 500 grams. We're still going to go from 20 degrees to 100 degrees. The difference this time is the specific heat, because we've changed materials, so we need the new specific heat value. And so if we come over and find aluminum on the chart, we see that the specific heat is doubled. So it's 0.22. And if you remember from the earlier lecture, the higher the specific heat number, the more heat it's going to take to change the temperature of that material. So our Q value should be higher for this pan. So let's plug the numbers in. So 500 grams, 0.22 for specific heat, and then the same temperature difference. And when we do the calculation, it makes sense that it's doubled because we doubled the specific heat. And so we get, for the aluminum pan, 8,800 calories. So the last question on this slide was, which pan would heat up first? And the way you figure that out is you're looking for the pan or the object that requires the least amount of heat. Whichever one requires the smaller amount of heat to do the temperature increase, that one's going to heat up fastest. And so in this case, it's going to be the pan made out of iron, because it only requires the 4,400 calories. So once it hits that number for heat addition, it will be already at 100 degrees, while the aluminum pan is going to be still waiting for another 4,400 calories of energy before it hits the 100 degree mark. So that is the solutions for the specific heat problems.